Okay, so you know how like online services are always talking to each other, right?
Right.
So today we're going to like really dig into how to make those conversations super secure.
Absolutely.
Yeah. Using something called mutual TLS.
MTLS.
MTLS, yeah.
Yes.
It's like
Yeah.
the ultimate way to build trust
Yeah.
between different services. You know what I mean?
Yeah, it's like the gold standard for establishing trust in the digital world.
Exactly.
Yeah.
We've got some great sources that lay out a complete strategy
Uh-huh.
for like implementing MPLS across a whole organization.
Yep. Whole organization.
It's all about creating this really strong foundation of trust and security for like all those internal communications.
Yeah, for everything talking to each other internally.
Exactly. So we're going
Yeah.
to take you through this approach like from the very basics all the way to how you handle those tricky connections to the outside world.
Sounds good.
All right, so let's start with the core of it all,
Okay.
establishing trust.
Right. So what's super important here is the certificate authority
CA.
infrastructure. Yeah, the CA infrastructure.
Okay.
So think of it like a digital government issuing IDs.
I like that analogy.
Yeah, so the most secure way to do this is with like a hierarchy.
Okay.
You have an offline root CA,
Uh-huh.
which is like the central mint.
Gotcha.
And then you have online intermediate CAs that handle the day-to-day issuing of certificates.
So it's like a chain of command.
Exactly. And this way, if one of the online CAs gets compromised, the impact is minimized because the root CA is safely offline.
That makes a lot of sense.
Yeah, it's a really important security principle.
Okay, so we have this trusted issuer now. How do individual services actually get their secure IDs?
Right. So each service gets a unique verifiable identity
Okay.
using something called a BY509 certificate.
5509.
And what's really cool is we use something called subject alternative names, or SANs.
SANS, all right.
It's like having one digital passport with multiple names on it,
Oh, I see.
right? So the identity becomes flexible. It's not tied to a specific server or anything like that.
So it identifies the service itself.
Exactly. The service itself, not the machine it happens to be running on.
Gotcha. So they have their IDs now. How do you actually distribute all these digital certificates securely to potentially hundreds of services?
Yeah, that's a big challenge, right?
Yeah, that sounds like a logistical nightmare.
It can be, but luckily there are some modern solutions.
Okay.
One is to use secure secret stores
Stores.
like HashiCorp Vault or AWS Secrets Manager.
Oh, okay. I've heard of those.
Yeah, they act like digital lockboxes for these certificates.
Uh-huh.
Then you have dynamic systems like SpiffSpire,
Spire.
which automatically issue certificates based on a service's identity.
That sounds pretty slick.
It is, yeah, it really simplifies things.
And for folks using Kubernetes, there's Cert Manager.
Right, Cert Manager can automate all of this within the Kubernetes environment.
Okay, so this is all great, but it sounds like a lot for developers to manage.
Yeah, I can see that.
Is there a way to implement MTLS without requiring them to like rewrite their whole applications?
Absolutely, there is. And this is where service mesh technologies come in.
Okay, service mesh.
Things like Envoy, NGINX, Istio-Linkered Console.
There are a lot of them.
Yeah, there are quite a few options.
Okay.
And they often use what's called a sidecar proxy.
A sidecar proxy.
Yeah, but picture it like a security detail that travels with each service.
I like that.
So this proxy handles the whole MTLS handshake behind the scenes.
So the application doesn't even know it's happening.
That's right. It's totally transparent to the application code.
That is a huge efficiency boost.
It is. Yeah, it really makes things a lot easier.
But those digital certificates we talked about, they don't last forever, right?
Yep, they definitely expire.
So how do you keep them up to date?
That's where lifecycle management comes in.
Lifecycle management.
Yeah, and this is critical.
Okay.
Certificates need to renew automatically, well, before they expire.
Before they expire. Okay.
Ideally around 2/3 of their lifespan.
Okay.
You also need graceful rotation, so there's no downtime for the service.
Right. That makes sense.
And if a certificate is compromised, you need robust revocation mechanisms to quickly invalidate it.
So you can shut it down, essentially.
Exactly. And it's also crucial to maintain a complete inventory of all your certificates.
Oh, okay. Why is that?
Well, this helps prevent outages and security gaps.
I see. So you can keep track of everything and make sure nothing falls through the cracks.
Exactly. It's all about staying organized and on top of things.
Makes sense. All right. So you have the whole system in place now. How do you actually roll this out across your infrastructure?
That's a great question, and the key is to do it gradually.
Or we do okay.
Yeah, a phased rollout is the way to go.
Okay.
So you start with less critical services, and you can put them in a permissive mode at first.
Permissive mode. What's that?
So MTLS is attempted but not enforced.
It's like a trial run.
Exactly. Then gradually you introduce those sidecar proxies we talked about.
Okay.
And eventually you move to strict enforcement where MTLS is required.
Gotcha.
And another important tip is to create security zones.
Security zones,
Yeah, to isolate protected and unprotected services during this transition.
so you're minimizing the risk.
Exactly. It's a much safer approach.
That sounds pretty practical.
It is, yeah. It's all about minimizing disruption.
Okay, so now for the real world stuff.
Yeah.
What about when these services need to talk to the outside world?
Ah, yes, external communication.
Partners, external APIs, all that.
Right, that definitely adds another layer of complexity.
I bet.
Yeah, you need to handle TLS termination at your network entry and exit points.
TLS termination.
Right, and you have to manage certificates for external partners who might have different security practices.
Yeah, that could be tricky.
It can be, and you might also have to deal with older systems that don't fully support MTLS.
So you need to figure out some workarounds.
Exactly. It often requires careful negotiation and bridging strategies.
So it's not always a simple plug-and-play situation.
Not always, no.
Okay, so to sum it all up, implementing MTLS across all your services is a pretty involved process.
It is, yeah.
But it seems like it's absolutely fundamental for building secure and trustworthy interconnected systems.
100%. It's the foundation for establishing strong trust in today's digital world.
And our sources provide a really structured and adaptable framework for doing just that.
Yeah, they do.
So for you, the listener, as digital services are becoming more and more interconnected, how might understanding these core principles of MTLS change how you look at the security of different platforms and technologies?
That's a good question.
Maybe it'll even lead you to explore things like zero trust networking, or take a deeper dive into some of the specific technologies we've talked about today.
I hope so.
Thanks for joining us for this deep dive.
Yeah, thanks for listening.